Good afternoon, everyone, to the Sharjah Research and Technology Innovation webinar here today. I have with us a prominent speaker, Professor Ayman. I will give it a couple of minutes because we generally see that it takes maybe about 60 seconds for most of our participants to join us. And, so I will probably give another 30 seconds before we start the session. Meantime, I will just get the slides up and running. Oops. Okay, good afternoon, everyone. My name is Shafir. I represent the Sharjah Research and Technology Innovation Park. Today, we will be covering a very unique topic, and we have a key expert here with us. But before I introduce Professor Ayman, I would like to quickly go over the initiatives and the objectives of the Sharjah Research and Technology Innovation Park here in Sharjah. Of course, the Sharjah Research and Technology Innovation Park has stemmed from the leadership of the United Arab Emirates. Of course, His Highness Sheikh Khalifa bin Zayed Al Nahyan, the President, His Highness Sheikh Mohammed bin Rashid Al Maktoum, the VP and ruler of Dubai, and of course, most importantly, His Highness Sheikh Dr. Sultan bin Muhammad Al Qasimi, the ruler of Sharjah, and also the chairman of the Sharjah Research and Technology Innovation Park. The park itself was established back in 2016, initially through a tie-up with the Fraunhofer IPK and the Board of Trustees, getting together and understanding the existing capabilities and the potential opportunities in the region. This led to the Emiri decree that established the park. Of course, the Emirate of Sharjah happens to invest over $1 billion annually in research and development, in education, innovation. And this is the primary focus for the development of the park. The final end game, so to speak, is to be the forefront of technology and innovation. We were in stealth mode up until 2018. We started operations towards the end of 2018. 2019 is when we had commenced the operation and started onboarding some of the vast technology companies that we have within the park today. Just to quickly go over the key mandate of the Research and Technology Park. Of course, primarily we are looking to build an innovation ecosystem. While we are young, we are growing with the number of companies that we have onboarded. And the idea is really to support our partners to scale and build their technology advancements and provide an opportunity to test these solutions and ultimately deliver commercial benefits. We wouldn't be here where we are today if we do not generate employment. We really want to access the vast talent that we have available to us within Sharjah, being the capital of education, so to speak. We really talk about knowledge economy, but being under the stewardship of His Highness Sheikh Dr. Sultan, we really are looking to rapidly commercialize research and development through the promotions of circular economy, and really pooling in the talent that is available to us. Ultimately, all this is to really invest for the future. If the last 12 months are anything to go by, we really cannot predict what the next 5 years can hold for us. So we really are making to ensure that we are at the forefront of innovation in this rapid acceleration. The primary focus of the park, once established, has been across 6 main areas. Of course, we have been pivoting over the last 12 to 18 months. We have been covering segments of water technology, the environment technology, renewable energy, digitization, including healthcare technology, cybersecurity, artificial intelligence, and so on, mobility, logistics, and smart cities, and ultimately production, design, and architecture. Of course, being one of the foremost parks in the region, while we do have a regional mission, our vision has been global, and we have been identified and supported by several international entities, as you can see across the screen. And several of these are entities that we work with very closely in advancing technologies across the 6 realms that I mentioned earlier. We have a unique process of how we actually collaborate with several of our entities, and we are in a unique position. And we like to call our mode of operations a triple helix activity-based technology transfers operational aspect. So what this means is that while we are a government entity, we work very closely with several businesses, conglomerates across the region, and we are heavily linked with the academia as well. Just to give an example of how we support our partners in this way, I would say we have a startup that is actually developing artificial intelligence solutions over the last 2 to 3 years. What we have done is we've actually linked them up with one of the government entity here in Sharjah, and developed a pilot program for 15 sub-government entities across the assessment of artificial intelligence and their readiness. We link them with the business module of large conglomerates such as Gulftainer and Crescent Enterprises, and supporting their artificial intelligence. So we really collaborate with several of these academic institutions, with the business entities, and being a government entity ourselves. And so we have a holistic approach in how we develop our solutions. And the idea is to have a really all-encompassing ecosystem where we're able to support several partners and develop new technologies ultimately in their actual execution. Very quickly, going over the establishment of the park itself, we're proud to say that between 2019 and 2020, we've already had over $100 million worth of investments across several pilot projects within the park. We are already home to 6 anchor deep tech pilot projects, which in 2019 alone, we're aiming to achieve the same number across 2020 and 2021. Of course, this covers the areas of photovoltaics, agri-tech, 3D construction, additive. We have one of the largest additive manufacturing hubs in the region, second only to potentially Ankara in Turkey. We're developing the second stage of the AR/VR experiential center, and we are home to one of the largest, if not the largest in the region, mass transportation innovation center, a 3-kilometer stretch pilot project, which I will go into a bit more detail down the line. So we are already home to over 100 entities of different sizes, between startups, early stage startups, to SMEs with over 50 to 80 employees. And of course, one of the important aspects is that we happen to be located adjacent to one of the largest talent pools in the region. So a 3.8 square kilometer radius of 22 institutions housing over 50,000 students. And I believe this would be one of the highest concentrations of PhD holders in the entire region. Very quickly, some of the entities that are established here with us today. Arnab is focused on micromobility. Skyway, I will go into a bit more detail. Soy Lab happens to be our open innovation lab for rapid prototyping, which I will discuss in detail as well. So you can see a broad mix of startups and conglomerates and SMEs that are established with us. So we really are proud to have an all-encompassing ecosystem. One of the activities that our CEO, His Excellency Hussein Al-Mahmoudi, conducted in 2019 with a senior delegation, including His Highness Sheikh Fahim and other members of the government entities in London, was to present a benchmarking activity of Sharjah with 9 other cities around the world. That includes Boston, Frankfurt, Bangalore, Hyderabad, and so on. And this was presented actually in the House of Lords, covering several segments such as markets and investments, knowledge development, research facilities, developing skills and human capital, where infrastructure really needs to go, and of course, the governance and policy that would need to develop to support the forward thinking of innovation. I would like to very quickly go through a few of the entities that are established here within the park. Skyway is a Belarus entity that is developing one of the largest transportation innovation centers here in the region. As you can see in the images here, we actually inaugurated a small stretch of 500 meters back in 2019, which is inaugurated by His Highness. After this successful pilot, we are now developing phase 2 and phase 3 in parallel, which is actually a 3-kilometer stretch of people moving transportation system as well as logistics as well. So we're quite excited about the logistics pilot, which would actually move 40-ton containers at approximately 150 kilometers an hour. So we really are expecting a game changer in the logistics segment with this company. Berlin Technologies covers different segments. They're into vertical farming, agrotunnel, aquaponics, and hydroponics, and also developing sustainable construction solutions. And I'm proud to say that we have several clients already for this entity, not just for the vertical farming and their produce, but also for their sustainable construction segment as well. Civil Twin Renewables is a startup from Spain, developing a new solar technology, which is the first phase has been completed, where they've installed 6 arrays of solar panels, and we aim to test these panels. Hopefully they would generate 20% additional efficiency with a 10% reduction in footprint is what we're expecting to see. Some exciting times with this entity. Naphtha Health is another proud startup by a woman for women health. Initially started off as a digitization exercise, and Sophie is now developing specific technologies and tools for the assessment of women's health. And we're proud to say that Sophie is now expanding into the Saudi Arabia market as well. Really proud to support women entrepreneurship. Proud to say that at present we have about 15% of our entrepreneurs women, and we're really driving and hoping to increase that numbers over the next 1 to 2 years, hopefully towards the 30% mark. Sharjah Open Innovation Lab, or SOI Lab, as we like to call it, happens to be 3 floors of rapid prototyping equipment. And this enables both the early stage startups and SMEs to have access to different kind of equipment, whether it is 3D printers of metals, plastics, polymers, or CNC and laser cutting machines for wood, textiles, and so on and so forth. So really, the idea is to have access to several of this equipment for even electronics to early stage entrepreneurs who may not have the funds to actually purchase some of this equipment that runs into the millions. But we provide it more or less like a gym membership to these clients, and really hope to drive innovation through this. And another initiative that we have just launched back in December is the Sharjah Angel Investors Network. It was actually initially a soft exercise to get together, as you can see in the images here, about 25 angel investors from Sharjah and the Northern Emirates, and we put together 10 of our startups. We're proud to say that even through these early 2 exercises, 2 of our startups already were able to generate investments of between 500,000 to 1 million dirhams. That is roughly approximately, I would say, 300,000 US dollars just in the first 2 rounds informally. And now we've actually expanded it, and we will be formalizing the Sharjah Angel Investors Network. So watch the space for some more exciting activities. Just to very quickly wrap up, we have been conducting several activations across the globe. Of course, the last 12 months have been more of a virtual environment. We've conducted several events, including the Women in Technology and the MENA Innovation Technology Transfer Summit, that attracted over 5,000 participants between them. We have been conducting over 50 webinars in the last 12 months. And we've been proud to say that we've attracted over 30,000 attendees so far. And obviously, we are moving more towards a hybrid model in the last 2 to 3 months with the support of the government. So we conducted our first live exhibition, well, after COVID time, so to speak, in our brand new HQ between November and December, where we had 25 different entities who are developing 3D printing solutions for, again, plastics, polymers, metals, and so on. It was quite successful, where we had 15 different government entities actually come down, social distance, of course, to have a look at these technology. And we had several private participants in the exhibition as well. Please stay tuned for other activities. We will be launching our Smart City exhibition potentially in the next couple of weeks as well. We were intending to launch it this month, but with the new restrictions, we decided to give it a pass and be ready for the new regulations to come through. Without much further ado, I would like to conclude my discussion here today, and I would like to pass on the microphone to our esteemed guest here with us today, who is Professor Ayman Maaitah. I hope I pronounced that correctly. Professor Ayman is actually a professor of mechanical engineering, and he's obtained his PhD and Master of Science from VA Tech in the USA between 1985 to 1989. He is the Vice President of the American University of Mataba, and he's been the acting president in 2011. He is a winner of the American Award for the Innovation Project in 2015, and also the winner of Golden Prize of Emirates Energy Award in 2013. He has been decorated with the Al Hussein Medal for Distinguished Achievements of the First Degree in 2014 by His Majesty King Abdullah II, declared as an UNDP expert on renewable energy, has been a NASA Research Associate 1989 to 1990. Of course, most importantly, he's an inventor with over 16 patents registered in the US and 32 European Union countries, as well as Australia, China, South Africa, and the GCC. He is responsible for publishing over 100 publications: solar energy, wind energy, thermal fluid systems, hydrodynamic stability, nonlinear vibration, and applied mathematics. And of course, he's an entrepreneur and founder of the Millennium Energy System since 2002. He's also currently the CEO of the Renewables and Precision Industries in Dubai and the general manager and partner at Wahaj Investment in Dubai. Of course, he's been involved in executing several pioneering projects in solar energy locally as well as internationally. Thank you very much for your precious time sharing with us, Professor Ayman. I would like to pass on the microphone to yourself. Thank you very much.
Thank you very much, Shafia. Thank you very much, everybody. It's really nice to be with you this afternoon. So I believe today's seminar is about solar thermal applications or webinar. Can I share my screen?
Yes, please.
Let me share my screen so that okay. I think what we do should this type of sharing easier. Okay. I hope you all see my screen now. All right. So I will start immediately for a matter of time. I'll be talking about the concentrated solar power. Why is it used for, and why this type of technology is gaining more and more attention worldwide. And meanwhile, I'll be talking about our latest innovative solution, which is the state of the art of a new concentrator called ASC. In this first slide, you can on the left you see the previous state of the art concentrated solar power system already existing in Masdar Institute in Masdar City. It's called the beam down, and on the left is our innovation that I will be talking about. So the most important aspect for concentrated solar power, or we refer to it CSP, is storage. So why storage? Why should we shy away? Why are we doing something extra to photovoltaic, which we know that photovoltaic is now probably the cheapest cost of electricity worldwide. It's even beating coal and natural gas. Well, the idea is the storage. The only way to store electricity from a photovoltaic is to do it via battery, and this has so many constraints. First of all, it's limited storage time, and it's expensive, and it did not develop to be on a large scale storage. So why storage? There is something we call the duck shape. What is the duck shape? This is the basic load on electricity of any grid. The dashed line, we call it base load, which is the load that runs constantly day and night, every day, every time there is the minimum load that operates day and night is this, we call it the base load. Then there are the load varies, as like in the morning when people wake up, they turn on their electricities, and then in the afternoon, in the after sunlight, they also do that. So the load, there is these two humps, two peaks. So that is the shape, that is the regular load of basically any grid. It varies from one grid to another, but this is the basic shape. The solar energy is there. It's in the middle of the day. The solar energy is here. So again, so this is a real load profile. The gray line is the original curve of the load. Then as we increase the solar energy, you see that we cut the first peak, and as we increase it more and more and more, the load on the traditional electricity is going like that shape, which we call it the duck shape. It looks like a duck because it has this neck here. Now you can see within like 1 hour to 2 hours, there is a sharp increase in demand of load. To generate this electricity, this is very, very expensive electricity. We need to generate it by the most expensive methods ever. We're basically burning diesel or something like that. And this is also creates a hardship on the equipment. Many of the equipments that we use or grid operators use, it sits there all the day to run for only 2 hours, and it just only to catch up with this piece. So if we have storage, if we store the sun electricity during when we really don't use it much, and distribute it over here, then we basically get rid of this problem. We basically get rid of the duck shape profile. Another important aspect, why do we need storage, is that the sun shines basically 20% of the time over the year. So the limitation, if we don't use the storage, if we generate non-dispatchable electricity, meaning that we generate it, we have to consume it on the same time, but that we generate it, we are limited. Even if we disregard the duck shape, even if we disregard all other things, we can only operate it for take it for 20% of the time. But if we do storage, potentially, theoretically, we can go for 100% of the time. Okay, so that's why the concentrating solar power is used, because it provides low cost, long duration storage. And for the last 100 years, only 4 types of basic concentrators are used. This is the most common rising star right now, called the heliostat towers. These mirrors, they concentrate solar radiation into a receiver on the top. For example, the latest DEWA project, this receiver is about 230 meters up in the sky, from the ground, and there are like 300,000 mirrors, all with the motors computerized to concentrate solar energy to that receiver. And they use this high temperature for storing heat in form of molten salt, and this system can generate electricity for about 12 hours to 15 hours. So this is long term, and this is in the night. So usually the DEWA project, for example, operates from 4 p.m. until 10 a.m. To generate electricity, solar electricity in the night. So that's important. It has the main 2 disadvantages. First of all, the optical efficiency is low for this system. which means only 40 to 60% of the solar radiation can theoretically be concentrated here. Theoretically, and practical, it's even less. And it cannot be distributed. The lowest capacity they can operate is 100 megawatts. So it's utility scale. This cannot work for like farms or industries or small scale. The parabolic trough is the oldest technology, but it has only short-term duration of storage. This is what we call linear Fresnel. It does not do electricity, and the parabolic dish does not do any type of storage. I will not go into details, probably when something else. We have developed a new type of concentrator. We call it the ASC. It's basically a metallic lens. It's not a lens, it's like a lens, but it's composed of reflective conical reflectors, nested rings that concentrate solar radiation to a fixed focal point on the ground. Why it's fixed? It's fixed. It's very important that this is fixed because we can easily access this heat. We can easily access this high temperature heat. We reach to around 1,500 degrees centigrade, and I will show you videos on this fixed receiver. We take this heat and we do whatever we want underneath it. So we do have a solar furnace fixed on the ground, and while this goes tracks the sun all the day, we actually get it in the night. This is a patented invention. It has about already 6 registered patents, and we are also filing it for another 150 countries worldwide. And these are some of the patents of the technology, and it has been vetted by some of the most important institutes in the world, like the DLR, Fraunhofer, Florida Solar Institute, City University, French Center, National Lab, DIWA, Masdar, NG Labs, and also currently is being vetted by the National Research Energy Lab, NREL, in US. The application of such technology is that we can store energy in the cheapest way possible. We basically, Bill Gates said, if you want to do something cheap, do it as cheap as dirt. So we basically store it in rocks. We heat hot air, and we pass the hot air through a box of gravel, rocks, or maybe ceramic material. And so this gets heat up. And whenever we want to get the heat back, we pass cold air from the bottom and we get hot air on the back. This technology is known and it's called packed bed. Packed bed. So there are details about it I can refer you to. So we have high temperature receiver here with hot air. We pass air all the time, during all day, and heating these rocks, which are included in a insulated container. And in the night, we pass the air from below, heat it up, generating steam, and the steam will run a steam turbine for electricity. So we can generate electricity anytime we want it, anytime we want it. Many other applications. I will be skipping more details, but you can imagine we can power something called combined cycle gas turbine, in which in the first stage we run a gas turbine and the exhaust run a steam turbine. This is very efficient cycle. The solar to electrical efficiency is 40 to 50%. Comparing that to the photovoltaic, which is 17%. So we have 3 times the efficiency, or more than 3 times the efficiency of PV. What does this mean? This means we have 1/3 usage of the land. We use 1/3 of the land. So if a PV needs 3,000 square meter to operate, we need 1,000 square meter. Now, in many applications, this is important. This technology have been tested using a parabolic dish, but as the parabolic dish moves in the sky, this technology was failed to operate. In our system, this gas turbine will be really sitting on ground, and I will show you how. Of course, we can use it with existing power plants to reduce its carbon footprint by generating steam to run in the daytime, while in the night we rely on fossil fuel at the beginning. Later on, we use the storage to be 100% solar. There are dying coal plants in the world. They try to commission it, and we prevent a solution to do that in a two-step solution. Another application is we can generate, because of high temperature we reach, we can generate hydrogen from splitting water, green hydrogen. And we propose a solution called the thermochemical or thermolysis process, in which we use the heat to split water into oxygen and hydrogen. And there are papers already published about that. This is much more efficient than the electrolysis process used currently. Of course, we can generate for very few, this is distributed. We can start generating by powering a Stirling engine. We generate from few kilowatts. Then we can go and generate 100 kilowatts into a microgrid, and we can couple our system with a PV so that the photovoltaic operates in the daytime, where it is still the cheapest daytime operational electricity. But in the night, we store our electrical system to run it, to run our system, to run our ASC, to run our turbine. And actually, we can also generate cooling as a byproduct. So this is really good for new development sites. And we use 25% of the area of PV and less than half of the cost, less than 50% of the cost. Of course, water desalination, this can be done, and we can show you here. I will go quickly. We can generate cooling for 24 hours. We can industrial metal melting. We generated a lab scale small system in 2017. This is about 40 centimeter in diameter. And we powered the small Stirling engine. This is just a demonstration. This engine we used to burn fuel to make it operational. Now we heat it up by solar energy. Please note that this engine is sitting on the ground, while in the Stirling dish engine, this engine has to move and be moving in sky. Just this is demonstration, but I will show you. We built actually a commercial prototype. Now I will show it to you. So, and we generated electricity from that. Okay. All right. So later on, we did the 10 meter in diameter. We did a simulation, but we built it. We found out that we can concentrate solar energy by thousands of times, and we have the system there. Let me show you some of the test results of that system. That system can provide 65 kilowatts of electricity, 10 meter in diameter. A power plant, we can combine this together. We can combine these systems together to generate megawatts. We actually have designs for, we showed you 300 kilowatt. We have plans for 1 megawatt and 5 megawatts with 12 hours of storage that can operate in the night. What I want to show you actually is some of the test results. If you excuse me a little bit, okay. So that system is now in Masdar Institute. We bought steel and aluminum and brass plate at the focal point, and then we track the sun by moving the concentrator to face the sun. First, we bought 2 millimeter aluminum plate, and you can see immediately start melting. This means we already reached 700 and above degrees centigrade at this focal point, but I will show you that we exceeded 1000 degrees centigrade or Celsius. But see, within a few seconds, it made a full hole. we did not expect that. It make a full hole immediately. The beautiful thing is that also this hole diameter is 25 centimeter, which is near exactly. We designed it for 25 the diameter in centimeter in diameter. Later on, we put brass. And we burned the hole in the brass again. So here, what I want to show you, and our simulation, the focal area is between 125 to minus 125, which is 250 millimeter, which is 25 centimeter, and this is exactly what we burned. And these are the high concentration, and this is exactly what we got. Also, we managed to generate heat enough to melt steel. I will not waste your time with that. I will show you the video later on. Even for a very low solar radiation, DNI, we managed, which is 500, which is half of your average daily DNI. We managed to reach 1,000 degree easily. We actually have to defocus it because we don't want to melt our sensor, temperature sensor. For birds, everybody was okay, solar concentrator kills birds. Now this is, here the temperature is about 1,000 degree, and here the bird is enjoying the shade. We are bird friendly, and we don't shy upward. You know, the Masdar Institute is near an airport. The shining service is below, is shining below. The upper service is not shining. So the planes and everything does not see a shining. There is no danger of that. And also this actually help us into basically cleaning. The dust is accumulated on the outer surface, which is non-shining. The shiny surface is protected, is in cocoon. So we have created and developed a new concentrator that have so many applications. It's modular, which means that it can start from few kilowatts to hundreds of kilowatts to megawatts to utility scale. It is distributed. It have many applications for industrial heat process, for hydrogen production, and for electricity generation with storage. And it is the cheapest storage, the cheapest solar storage system right now in the world. And thank you very much. I hope I did not exceed my 20 minutes limit.
No, not at all, Professor Ayman. This is really fascinating to see all these different technologies, and I really hope that we can collaborate here at the Sharjah Research and Technology Park. Actually, probably just a side note, a very interesting coincidence is we actually met with Karam yesterday from Ultimate Engineering, and he actually showcased the development of this technology.
Yes.
So I guess it's a very pleasant coincidence to actually have Professor Ayman here on our webinar. It's the very next day. I would like to kick off with a question from our end, and probably just pick a little bit at the relationship between 3D modeling and developing this technology. Of course, in this day and age, we are moving towards digital transformation in developing some prototypes. Perhaps a bit more of a technical question, but how would you say these digital modeling has assisted yourself in developing these technologies? And where do you think we can go from here, from the digital modeling to the actual fabrication and construction, of your test facility?
Actually, the digital modeling was crucial into getting all of that. I did not go through all the details because I had to be restricted with the time. The digital modeling, if it was not for the digital modeling and with the relatively limited resources that we have, we could not go from the vision I had in my mind to something operational within this short time. Karam, for example, and people like him, they were crucial into getting this system operational and getting it well done and corrected. The 25 centimeter, the location of the focal point was all done thanks to Karam's rigorous simulation. We did so many mistakes in the digital. We can afford doing mistakes. We can afford playing around until we get everything done. So this is very that was crucial, and I have to admit, if it was not for digital modeling, we could never have reached to this level with so much limited resources and so much short time. On the other hand, that will help us in the we are thinking about 3D printing of some. Right now, the 3D printing is limited in size, but for some parts, like in the receiver, some parts of the concentrator, especially the most accurate parts, we are thinking about 3D printing. And to do 3D printing, you need first to do digital modeling. We made sure that our system is wind load safe. We made sure that the location is there. So that was important. The digital modeling is crucial. And again, if it was not for digital modeling, we could not reach to have such a operational prototype in this short time.
Fantastic. Thank you very much, Professor Ayman. In one of your slides, you had mentioned about large-scale adoption and in terms of developing a farm of these of the concentrators. How far off do you think we are in terms of probably being jumping a bit ahead of myself, but how far do you think we're away from large-scale production? Because consumers like myself are always looking. Our consumption is always increasing, unfortunately, but it's really thought leaders like yourself who are supporting the sustainability angle by making sure that the energy we generate is clean, and the newer generation is always looking to substitute this consumption with sustainable consumption. So we're always watching with open eyes to see where this new technologies will take us, and we'd like to see this in application. So probably in a nutshell, my question is how far off do you think we would be in terms of large-scale fabrication and potentially implementation of technologies such as this?
Of this technology, for example?
Yes. Yeah.
We are not that far. Actually, we are not that far at all. We already have a commercial scale prototype operational in Masdar. We have so many, let's say, few projects in the pipeline. We for industrial heat, we are talking to some mining company, the phosphate company in Jordan. They need high temperature heat for their phosphate operation. There are we are talking with we are joining forces with some universities in Saudi Arabia for pilot projects funded by KA Care. We have been approached actually by the electricity company of Arizona, APS, Arizona Power Services. They are very much interested into our technology for microgrids. So no, we are not far. Actually, we are just waiting to finalize a project to start the full-scale production. The system is this system, for example, is made from locally and readily existing materials. There is no special materials. The innovation of this system is design, engineering, and mathematics. There is no special materials or special hardly obtained technology. To manufacture it, there is no need for special power plant production lines or special training of the worker. They are like steel workers, welders. This whole thing is manufactured in Dubai, in UAE actually. So this system especially is not far away from a mass production. The only thing is that it's waiting to finalize the project to start launching it. And of
Inshallah,
course,
inshallah.
inshallah, investment is
Inshallah.
there, but needed there. We need the investment to boost up our operation. But the final system is not much different from what you see in front of you. So it can go immediately.
Fantastic. We have a question now from one of our attendees who are asking, how does the efficiency compare to parabolic troughs?
Yes, thank you for this question. The theoretical efficiency of parabolic trough and our system are the same. It means there's something we call the concentration factor, or some people like to call it incident angle modifier. Theoretically, the parabolic trough is 100%, and we are 100%, meaning that all the solar radiation falling on the cross-sectional area is concentrated on the focal point. There is no angle cosine modifiers, and like it is the case for the heliostat tower. Also, I think that the specialists will understand my expressions. Also, the actual, although theoretically is 100%, but actually it is 91%. The optical efficiency of our system is 91% because of reflectivity factors, because of so many things. It is practically, we measured it to be 91%. Theoretically, this will be the same as parabolic dish.
Fantastic. Thank you very much, Professor Ayman. We have a follow-on question. It says that our requester, Mr. Riyad, has said that he means in terms of areas as well. I'm not sure.
It's the same area. The same area you need for actually in Masdar, next to it, there is a parabolic trough. I should have showed you this photo. It is of the same area. The same area needed for parabolic trough is the same. But since we are talking about parabolic trough, let me explain a slide that I skipped over quickly. Okay, so here is a sketch of the parabolic trough. The parabolic trough, the focal point is not fixed on the ground. As we track the sun from sunrise to sunset, the focal point moves. This means if I want to get the heat, it can also concentrate heat by very large concentration. But to concentrate heat to move this heat, high temperature and maybe high pressure heat from here to store it in a storage system there, you need to pass through these flexible joints. Now we know flexible joints can pass temperatures up to 100, 200 degrees, but not 1,000. With 1,000 degrees, you need to have a very special flexible joints, which are very expensive, and they are like used for space age and something like that. So there is no parabolic trough with the storage. That's why. And because the focal area is moving, while our focal area is just fixed on the ground. Another thing is that, let me go backward. Here is a photo of parabolic trough. Sorry. So this is a parabolic trough. You see, it's a solid surface. The wind flows through it. It cannot go. It's a solid surface. It's like a sail. This is a 10 meter in diameter. To generate electricity, you put about 1 ton weight, 1 ton to half a ton Stirling engine at a cantilever of 6 meter, an arm of 6 or 5 meters in width, and you have to move this in space. The wind really is a very heavy wind load on that. Our wind load, because we are composed of grill, wind can go through our system. It does not face a solid surface, as you have seen it. So we are only 10% of the wind load of parabolic trough. So we can go much larger in diameter than a parabolic trough. But the total occupied area of a parabolic trough is the same as the total occupied area of our system.
Thank you very much, Professor Ayman. We have one more question from Dr. Jamil. And you'd like to ask yourself about the storage in rock or ceramic. Is it better than battery? It's
Definitely.
interesting.
Definitely. Let me go back to this slide. Because it's a fixed focal point. Sorry. Forgive me, huh? Here's the storage in ceramic. Because it's a fixed focal point, we can pass this hot air, we can heat air, for example, which is very readily, to 1,000 degrees, and we pass it through a pack of ceramic. This can reach up to 1,000 degrees in centigrade. This ceramic, the lifespan of it is, okay, it's rocks, it's infinity. So 30 years, let's say. It's cheap. Our cost of system is less than 5% of the cost of battery. The storage system is 5% of the cost of battery. We don't have, we can store as much as we need. There is usually battery, PV plus batteries, they operate for 4 hours. We have no issues with high temperatures. You know, the Arizona power came to us because they had PV plus battery storage, and there was a huge power. There is a scandal if you follow up. There was a huge, they blow up because of that. Because you know, Arizona is desert, so it's hot. The battery they need cooling. It's problematic, and they blow up. The lithium-ion battery can store only for 4 hours. The commercially available systems, and they are very expensive, very expensive, and they need maintenance. Their lifespan theoretically 10 years and practically 5 to 8 years. But here we're talking about, and the disposal of lithium-ion battery is getting rid of it is this is toxic, right, material. So, and in fact, many people say that lithium or batteries system as they are now, they are non-renewable, because even if you use all the minerals in the world, they cannot satisfy the storage need of electricity worldwide. So that's why people are looking for a different solution than PV plus battery. For short-term solution, then okay, PV plus battery might be a good solution, but this is like a short-term backup systems. But long-term, solving the energy storage system in the world is definitely, it's till now it's not the solution. So I hope I answered the question.
Thank you very much, Professor Ayman. I have a, because we're shortly running short of time, for all the entrepreneurs in the audience today, because you've developed so many patents over the last couple of years, and especially in the field of deep technologies, with several getting into these sectors. What would your advice be to prominent inventors and entrepreneurs from this space? I guess not just in energy, but across the field of where you're developing prototypes, in securing your IP, because this is something that is still, I guess, growing in awareness, especially in our region, the Middle East, while it's more prevalent in the West, I guess in North America and in Europe. What would your advice be to inventors in this space, especially in securing and safeguarding your IP, before showcasing to the world?
It is very important, Shafir. For me, for example, especially when the technology, once you put it there, can be reproduced easily. If I sell my system to one company, they can just reverse engineer it so quickly. Then you really need to protect your IP. That is very important. And although we are not used to it, but the laws do exist in our region to enforce these IPs. There are laws. If you patent an idea, Depends how you probably need to consult with a good lawyer. You need to educate yourself. There are utility patents, there are design patents, there are commercial marks patents. There are so many variations of them, but you want to, as much as possible, protect your concept. If you protect, the more you are to a concept, then the more you are more protected. If you do that, once you register the patent, and for example in UAE, which I did, nobody can sell it, even if they go and manufacture it in another country where you are not protected in these countries. They cannot sell it in UAE. They cannot even propose it. Of course, they cannot also manufacture. By law, you are protected. So the patent is not. We used to think about patent as an academic. No, it's not academic. It's actually, it is commercial. It's expensive. This is the most. In this project, the most cost goes for patents. Actually, it's expensive, especially if you want to. You have to identify your market. We registered this for this system. We registered it in all countries of the world where there is great potential for concentrated solar power. That's why I mentioned so many things. There are locals and international patent offices in the world, and even in Dubai and Emirates. You can and Emirates in general, also in Sharjah and everywhere. You can register it at the beginning. You can do something not so expensive, something called provisional patent. Probably as an entrepreneur, you need to do it startup. It's not so much expensive, but later on to get to real protection, that will give you like a 1 year sort of a protection while you attract an investor, where you can show your technology for investors, for seed investors, and later on you go for the next stage in which you probably need to have a full protection. But it's very important to patent your idea, and the new ideas are not easily coming. By the way, especially for the young audience here, all classical works will be in the future taken over by artificial intelligence. What artificial intelligence cannot take over is innovation, creativity. So the value of new ideas, creativity of ideas is very precious, and it's always worth the money and the effort. And some patents take me 3 years, 4 years. Some patents was there within 1 year to do it. So I do urge everybody, if he have or she have a patent that she believes in and she thinks it's of value, especially of commercial value, to go ahead and patent it.
Thank you very much for those keen insights, Professor Ayman. It's been a pleasure to be with you.
Thank you.
Unfortunately, we're running short of time, but I guess we could go on and on for hours. I'm sure the topic is just so fascinating.
Thank you.
I'd like to thank all the audience members for participating today. I guess we don't have any. I will just quickly check. Okay, we don't have any further questions. Once again, thank you very much, Professor Ayman, for spending time with us and taking time aside from your very busy schedule with us. And hopefully we can collaborate together at Sharjah Research and Technology Park in the very near future.
I
wish you all the very best in your projects.
Looking forward for that, actually. Thank you very much.
Thank you very much, and wish all our attendees a very nice